Hello everyone, welcome back. So in this video we are going to understand today a contest problem that we have is reschedule meeting for maximum free time 1. So the problem is saying that we have given an integer event time. So this is the event time we gave in example 1. So event time is the total duration of a day, that is you can say time goes from t0 to t5. Can we say that? We can say that, right? Means total duration we have given of a day, and the event time is goes from t0 to t5, and so it is given event time is 5. Now another we have given is let's understand start time. Okay, so start time is also we have given like this. Okay, and this is an array. Similarly we have given end time, correct? So this start time and end time is when meeting already scheduled. So these two array we have given means start time and end time meetings already scheduled during the day, right? And k we have given is maximum number of meeting you can shift to start earlier. Okay, maximum number of meetings you can shift to start earlier while keeping the meeting in the same order. Okay, means the meeting order will remain same, but you can shift the start, you can start to you can shift the start earlier. Okay, understand? What are the things we have to keep in the mind while number of meetings shift we can do, right? First of all, meeting should be in the same order. Meeting order should be same, or we can say meeting in the same order. Then it is also saying it should keep non-overlapping. So two meetings should not overlap. Then it is also saying the duration is fixed, correct? And the third is saying entirely within time 0 to event time. Okay, means the k we have given is the maximum number of meeting you can shift to start earlier, while you have to keep in your mind these things: meeting in the same order, non-overlapping, duration fixed, and entirely within the this, right? And what is our goal? Our goal is to shift up to k meetings. Okay, right? Earlier, right? You can say earlier. Can we say that? We have to shift up to k meetings. Why? To maximize, we can say to maximize the large block of free time. Can we say that? During this day, we have to maximize the large block of free time during the day. Okay, so let's understand what the question is saying, right? So example 1 is saying that we have given event time, right, and it is 5. Then we have given k, we also given is 1, right? And start time we have given is what? It is given 1 and 3, right? Similarly we have given end time we have given, and it is given what? 2 and 5. So let's suppose if we are considering this example, right, where k is 1 and these things we have given. Okay, means the days goes from what? The days goes from 0 to 5. Can we say that? And there are two meetings are there. The meeting 1 is start from where? 1 to 2, means from 1 to it is going to 2. Meeting 2 is start from where? 2 to 5. Can we say that? or 2, sorry, 3 to 5, right? 3 to 5, because see, now the very first start from 1 and ends at, because see, this is start time, right? This is start time, so it, when it start time at 1, right, and another is start time is 2, correct? So meeting 1 start from 1, it will go to 2, okay, and another meeting will start at 3, it will go to 5, right? Because this is the end times we have given. This is start and this is end, this is start and this is end, right? So if we'll mark that like this, you can, if you'll divide like this, it will like, it will look like this, right? Means this is start and this is end, this is start and this is end. Okay, I hope you understand, right? So very easy, right? Give me 1 second, what I'm trying to say. So this is become your one meeting and this is your another meeting. Can we say that? And that is why I'm saying start at 1, ends at 2, starts at 3, ends at 5, right? Means this is start time. So start for I equal to 0 means start time will be where? Start time at 0, and for the meeting 1 is here. Okay, that is why we can say we have two meetings, meeting 1 and meeting 2. So you are allowed to shift how many meetings? Only one meeting here to the left, right? And we'll keep the same duration. Can we say that? We can say that, right? So now understand what is the longest free gap you can create, right? So now understand very important thing, right? So let's understand again the longest free time. Okay, what is the longest free time, the gap you can create, right? So if it is the original schedule, let's suppose if this is original schedule, okay, where time starts from where 0, it goes to 5, and from 0 to 1 we are free. We have meeting m1 is at 1 to 2, right? Then again we are free, then another meeting we have at 3 to 4, right? So this is m1, this is m2, again we have free time. Means two meeting we have 1, 2 and 3, 4. So we can say we have free time is from 0 to 1, that we call this one, and another free unit we have, let's suppose between 2 and 3. Can we say that? This one, right? 2 and 3. Okay, so we have these two free time. Can we say that we have these two free time? Okay, and so we can say the max is equal to 1. Okay, so can we say that if 0, 1, 2, 3, 4, 5 is the time, right, and it's a scheduled meeting, m1 and m2 is scheduled meeting, right? So from 0 and 1 we have, we are free, one unit is free before m1, right? Before m1, right? And similarly 2 and 3 before m2. Between m1 and m2 we are free, right? So the maximum free time we can say is 1 unit, right? Can we say that? Without shifting anything, without shifting anything, maximum free time is 1 unit, right? Without shifting anything. Can we say that? We can say that, right? So the question is, can we improve it by shifting, right? When k is 1, k equal to 1, when k is equal to 1, can we shift it, right? Can we shift? So we are allowed to shift one meeting because k is equal to 1. So we can improve it by shifting. So let's understand what are the options we have, right? Let's understand that we have option 1. What is option 1? If we'll shift the meeting m2, let's suppose you shift meeting 2 earlier, right? So we can move what? Move m2 to immediately earlier, followed by m1. Can we say that? So m1 stays at 1, 2, correct, and m2 becomes, can we say that, 2 or 4, correct? Means M1 stay at 1 2 here, but M2 goes to, it becomes to 2 and 4, right? So we can improve it by shifting meeting 2 earlier, right? And we can move M2 to immediately followed by M1, right? So M1 will stay at here 1 2, right? And M2 becomes at 2 4. Can we say that? So if M1 become here, so M1 is here now. Now M2 we have shifted, so this free time is now not free time, it become for M2, right? And this will become your free time. So consecutive we have M1 M2 meeting, we have consecutively stay here. So let's write again. So if time is 0 1 2 3 4, can I say from 1 and 2 we have M1, this is M1 window, and 2 to 3 we have from here to here is M2 window. We can say that, right? From here to here, if it is M1, then from here to here is M2. So M1 is at where? 1 and 2, and M2 is at 2 and 3. Can we say that? So this is your option 1. Okay. So in option 1, we have let's suppose we'll call about the free gap. What we have in the free gap? The free gap left is 0 and 1, that is 1 unit we can say. Then we have 2, that is, let's suppose in the last, right? Here 3 to 4 we have, right? And 4 to 5. So we can say that's 4 to 5. So free gap we can say is 1 unit. We have is 1 unit, and still not better. Okay. So max we can say is 1 unit. Now understand option 2. So option 2, we have to shift meeting M1 to start at 0, right? So previously, if you remember, M1 was where? At the same place. M2 was from 3 to 4, right? Let me change the color. So M1 was at same here. M2 was from here to here, correct? This is M1 and this is M2, right? If we will mark these things, right? These are the meetings. So we will shift M1 to start at 0. Let's suppose T is 0. And M2 will remain unchanged at 3 and 5, let's suppose. That is unchanged, let's suppose. We'll put in the last, okay? Or we can keep 3 to 4 itself, unchanged. 3 to 4, we can say. So this time we have shifted here, this place, right? So how it will become? It will become 0, 1, 2, 3, 4. So this is your M1 and this is your M2. Now you check the free gap. What is the free gap is there? From 1 to 3, give me 1 second. So from 1 to 3, how many units we have? 1 unit, 2 units. So total we can say max is 2. 2 unit is free, right? So we can say after shifting meeting 1 to the start, right? To the start using one allowed move, because k is given is 1, right? The maximum free time we can create is what? Between 1 and 3, right? Because 3 to 4 we have already meeting M2, and there is next is 5 is also there, right? So we can say our maximum free time you can create is 2 unit. I hope you understand. Let's understand the code. So what is our intuition, right? So our intuition, let's suppose, is meetings takes up space on the timeline, right? So free time, if we'll talk about the free time, right? So free time is equal to what? Gaps between meetings, right? So the meeting takes up a space on the timeline, right? And means if it's 0, 1, 2, 3 and 4 and 5 we have, right? So if any meeting is coming, means it's taking the space. We cannot utilize this space, right? If any meeting M2 is coming, we cannot utilize the space. So we can say any meeting that takes up a space on this timeline, right? And the free time is the gap between meeting. So if any meeting gaps is coming, let's suppose this is your so give me 1 second. So this is your free time, and we say that this is your free time, this is your free time. So this free time is a gap between the meetings. Okay, so if we shift up to k meetings earlier, right, number of movement is k, how many meetings we can shift is this, right? So if we can shift up to k meetings earlier, we might be able to merge the meetings together or move to the start, right? And we'll create a gaps elsewhere, that we have seen option 1 and option 2, right? So our goal is to slide the meeting closer together to maximize one big free interval, right? Like we have done, we have put M1 here and M2 we have from here to here we have left, right? So we got the space here we have put, and we have got the space, right? So from here to here we was free, right? So we can create like this. So maximum 1 week free intervals we have to return, right? And that is why we have to check the orders, right? So what we will do, we'll maintain the meeting order, we'll avoid the overlaps, we will not do overlapping, and then we'll respect the time limits also. So we have checked that we have used the time limit, event time is between this, we have not overlap anything, we have maintained the order. M1 will do first, then M2 will do after that, right? We have also seen that. Okay, so what is the approach to solve this problem, right? Understand. So if we will iterate over each meeting, let's suppose call I, right? So this is the event time we have given, the behavior start we have given, end we have given, right? So in the very first we can say iterate over meeting I. We will iterate so we can get the meetings. Then maintain a window. What we will do, maintain a window of last k meeting. Can we say that? So that the meeting last k meetings, right? That will start from what? I minus k plus 1 to I. We'll discuss about this later, right? So we have to maintain a window of last k meeting from this to this, from this to this, I minus k plus 1 to I. And for each window, we'll calculate the time taken by k meetings, and we'll calculate the interval right minus left, right? Let's suppose we'll, for each window, and we say that for each window, right, what we will do, we'll calculate the time, right? Time by k meetings, we can say by k meetings, right? That will take, let's suppose t. Then in next step, what we will do, we'll calculate the available time, calculate the available time, right? And that will come from where? You have the right minus left, you can calculate. So there, how we'll get the right and left? Let's suppose left will be at n time minus k, means this is your I minus k. If we'll do, we'll get the n time at I minus k. So if the meeting before the window, else will return 0. Okay, and the right will be at start time at I plus 1. If the meeting after the window, else will return what? End time. Can we say that? Else will return this one. Either will return this or this. And then we'll find the, we can say, max free time, as we have seen, right? In this current window that we are talking about for each window, right? We'll find the window. How we'll get the max free time in this window? We'll get right minus left minus t. This will give you the max free time. So we'll keep track of the maximum of all the windows. Okay. So now let's do some hands dirty to understand the code. So let me write some comments so you will understand, right? So what we need to do first, we have to find the total durations, right? And you will get the current, we have to add the current time, right? And you will get the left and right as we have discussed. You will get the free time like this. And if we'll remove the meeting from the living window, we will update the time right here. And finally we'll return the res, means the free time. So give me 1 second. So what we have given event time, we have given k, we have given start time, we have given end time, we have given, right? So in the very first step, we'll find the n, how we are getting the number of meetings, how many many meetings we have, right? We can find using start time, or you can get from the end time also, right? You will get the number of meetings, right? Sorry, number of the meetings we can find, right? Then in the very first step, let's suppose we want to store the result, the maximum free time so far, and that we will call result. Okay, so this is, we have to initialize the result to store the maximum free time found so far, correct? Next step, we'll define t equal to 0, means we want to initialize a variable to keep track of the total duration time of the current window of k meetings. Then we'll loop over all the meetings one by one. How? We'll make a for loop, and then we'll go for I 0 to n. So we will track with the help of getting one by one meetings. So let's suppose we will add the duration of the current meeting to total time t, and so we'll call meeting duration equal to end time minus start time, and you will get the t, right? So this is your duration that we will add to the current meeting. So we can say total time is t, and we'll find the end duration minus start duration. Start means end time means start time of the meetings, right? So we will get the meeting duration. Now in the next step, we want to determine the left boundary of the free time interval that we are calculating. If there is two cases will be there, right? Case 1, if the current window includes the free first k meetings, we can say that will come I is less than equal to k minus 1, then left is equal to 0. Otherwise left will come to end of the meeting just before the current window. So we'll write the left, and we'll check the conditions, right? If the current window includes the first k meetings, otherwise 0, else the left will be at the end of the meeting just before the current window. Understand? For that we'll find similarly the right, as we have find the end, means we want to determine the right window of the free interval. So there will be two cases also. If I is at the last meeting, right will be at the end of that day, that is called event time. And then otherwise we'll say it will go to the start of the meeting, that is called at I plus 1. Then we'll find the free time. How we're going to find the, we have to find right minus left minus t. It will give you the free time, right? And you have to keep track of all the meetings because we have made the for loop as we have discussed, right? Then if the current window is larger than the k, it will slide the window by removing the oldest meeting duration from T. Okay, I hope you understand. And finally, you will return the free time. Okay, I hope you understand. If you have any doubt, please ping me in the comment box and let me know the time complexity and space complexity. Okay, so I'll suggest to understand how we are going to find. We have not taken any extra spaces, right? So obviously space will become O of one time, and we are not taking, we are taking only one for loop. So O of n will be the time complexity. Okay guys, thank you for watching this video, and let me know in the comment section that you have understood or not. And thank you for watching this video, and please subscribe this channel so that you will get the premium videos. Thank you for watching this video.